Hi students and family members, let's review multiplication. Today in class, you can see we did a couple of problems together, specifically the multiplication problems. I'll go over the ones right now that we didn't complete in school today. Question 2. What number does the smiley face represent? In multiplication, we recognized that yes, multiplication is repeated addition, but we also talked about how each individually time we are adding a number, we're talking about total groups of a number. That's why we have four smiley faces. In this case, 4,578 is what that smiley face represents, because it's like having four groups of the same exact number, 4,578 in one group, and every single smiley face after that is the same exact representation, because multiplication is repeated addition. Number 3, Jack has 16 Jolly Ranchers. Joe has 4 times as many Jolly Ranchers as Jack. Write a number sentence to show how many Jolly Ranchers Joe has. You're going to see me write 3 letters here, and the students know that these letters represent responsibilities that they have when attacking a word problem like this. K is what we know. W is the question, or what we want to know. S is the number sentence that we determine that will help us solve this problem. Here's what we know from the problem. There's an individual named Jack, and he has 16 Jolly Ranchers. K is what we know, and what we know, I use bar models. This is where the bar model comes into play. A bar model is nothing more than a rectangle picture representation to show what you know and to develop number sentences. Joe has 4 times as many as Jack. In order to represent Jack, I'm going to show that I understand multiplication like we had mentioned earlier with the smiley faces. When we say he has 4 times as many as Jack, that means he has 4 equal groups of the same exact number as Jack, because that shows 16 times 4. So that's 2 groups of 16, 3 groups, and 4 groups of 16. Fill in each group with a 16, and you'll be able to determine what the number sentences need to be to solve for this problem. I know that Jack has 16, and I know that Joe has 4 times 16. So my one number sentence to determine Joe is going to be 16 times 4. That will be my number sentence to figure out how many Joe has. And as we've shown in the examples above, when we multiply, we use what's called an area model, which means I'm going to expand this number and determine the partial products of each by representing them in this box, and then add those 2 products together. The area model shows me that in this area, I'm doing 6 times 4, which is 24. And in this area, I'm doing 10 times 4, which is 40. And now I add 40 plus 24 to get my final answer, which in this case is going to show me how much Joe has. So Joe has 64 Jolly Ranchers. Now when the students come up with one of their final answers, I always tell them check back with the W. See what the question is actually asking you. In this case, it wants to know how many Jolly Ranchers Joe has. And it only wants me to write a number sentence to show that, which we've done right here. 16 times 4 equals 64. This is my number sentence that ultimately gave me the product, but they didn't want the product at all. They wanted the number sentence. So my final answer is 16 times 4 equals 64. You can see we did the product down here for 287 times 7, so we'll move on to the next page. We did the product for number 5 as well. I changed the problem. It was 54 times 65. To represent the following in a number sentence, I pointed out to the students today in class that the word equals actually in math means is. So an equal sign can replace this is. And the word times actually has the multiplication symbol to it. So when I rewrite the number sentence to represent this, I need to put the 32 first because that's how it's stated here. Is can get replaced with an equal sign. 4 comes first, then my multiplication symbol, which is followed by 8. In the bottom, it's a little more simpler. It says, write 2 multiplication sentences using 3, 6, and 18. Well, that means I've got to take 3, multiply it by 6 to get the final answer of 18. I can also use the commutative property, which means I can flip-flop these numbers. My 6 can commute over to where my 3 is. My 3 can change spots and commute over to where the 6 was, and it's still going to get me the same exact answer, which is nice because then that easily allows me to write 2 multiplication sentences. Earlier I talked about an area model, which again is highlighted here when I'm doing 14 times 4. But below is not an area model, it's an array. An array is a picture representation showing total groups of a number. In this case, we have 1, 2, 3, 4 groups of 14 in each group. But the product was also needed to be solved for. I needed to multiply to get my answer 56. We did this one in school today. Moving on to the third and final page, we completed number 9 in school today. You see the KWS chart, and I left 10 for the students to fill in at home. So let's read through this problem together. Mrs. Smith sold 4 laptops in her first year. In the second year, she sold 6 times as many laptops as the first year. In the third year, she was able to sell 4 times as many laptops as the first year. Here's what I know. Mrs. Smith is selling laptops. She sells them in year 1, year 2, and year 3. And what I know is that in the first year, she sold 4 laptops. Notice that I'm creating a bar model where the K comes into play. In the second year, she sold 6 times as many, which means my base bar of 4 now actually extends to 6. 1, 2, 3, 4, 5, 6. In each bar, there would be the number 4, which means my number sentence to solve for how many she sold in year 2 would be the total amount in each group, which is 4, and how many total groups. And the way you determine the total number of groups is by counting the boxes. I have 1, 2, 3, 4, 5, 6. So to determine how many she sold in year 2, it's 4 times 6. That's my number sentence. In year 3, she sold 4 times as many. So once again, I'm going to draw my base bar, which would have a 4 in it. In this case, it's 4 groups of 4 because she sold 4 times as many in the first year. And the number sentence for year 3 then is 4 times 4. I haven't pointed out the W yet because technically there's 2. Let's take it piece by piece. First, what I want to know for question A is how many did Mrs. Smith sell in all 3 years? In order to do that, I need a totally separate number sentence. First, I need to multiply year 2, which tells me she sold 24 laptops. Then I need to multiply year 3, and 4 times 4 tells me that she sold 16 laptops. And I can't forget about how many she sold in year 1, which was 4 laptops. Which means my number sentence is now 4 plus 24 plus 16 to answer the first question. 6 and 4 is 10, plus 4 more is 14. Carry my 1. Then in my tens, I add 1, 2, 3, 4, which shows me that she sold 44 laptops in all 3 years. And that's what I would tell the students to type down here. Mrs. Smith sold 44 laptops in all 3 years. How did I know that that was the actual question? I went back to the W and then flipped it into my answer. The second question says, she sold the laptops for $265 each. How much money did Mrs. Smith earn? Well, that means for each individual laptop, it costs $265 a piece. So I need to use my area model. This is a bit of a challenging question. My area model is going to be really big. I'm going to have a double-decker area model because she sold 44 of them. So that is 40 plus 4. And on the top, we've got 200 plus 60 plus 5. Now this is an area model that the students actually haven't had any practice with, so that's why the videos come in handy. Now I multiply. I showed the students that when we are multiplying multi-digit multiple numbers, you should cover up the bottom. The bottom will then just kind of get in your way and can confuse you. So I use this revealer on my computer screen, and I gave the students an index card so that they can just focus on what they need to multiply. 40 times 5. 5 times 4 is 20, and because this 40 has a 0 in the ones, I need to add it to the ones of my answer. 6 times 4 is 24, and because there's 2 zeros, I need to add 2 zeros. 4 times 2 is 8, and there are 3 total zeros, which fills in the bottom. I no longer need the revealer, but what I did tell the students to do at that point is you still need to ignore the spot that you've already completed, which is this 40. So we have them block it out, or in this case, I'm going to erase that 40 altogether. So now I'm only focused on my bottom numbers. 5 times 4, which is 20. 60 times 4, which is 24, and there's only one 0, so it's 240. And finally, 4 times 2, which is 8, with 2 zeros, which is 800. Now, some of the students are able to combine so that their addition isn't that difficult. What I mean by that is, I know that 800 plus 800 is 1600, or 1600. So rather than putting all of these numbers down the line, I combine those right away. I can also combine 200 and 20 and be able to solve that that's 220. These other numbers aren't as easy to combine, so I'm just going to rewrite them. 2400 and 240. But I will combine the 200 and 220, which gives me 220. Now my focus is only on adding. All zeros in my ones. 4 and 2 is 6. 4 and 2 is 6, plus 6 more is 12, plus 2 more is 14. Carry my 1. 2, 3, 4. Mrs. Smith, when I go back to the W, earned $4,460. I hope this video helped practice these problems in multiplication. I hope the students are able to follow the step-by-step process, take their time, and avoid mistakes. And I hope most importantly, they learned a lot about how we multiply throughout this unit. Thanks for checking out the video.